So you want to build a custom subwoofer box for your subwoofer. You get out the manual and you take a look, but unfortunately, there's multiple different values listed for the recommended volume. On the manual, you see a gross volume, you see a total internal volume, and then you see VB or air volume. Which is which? What does this all mean, and why is air volume important anyways? That, my friends, is coming on up. Hey, what's going on? Welcome to Car Audio Fabrication. I'm Mark, and here on this channel, I do car audio review videos, I do build log videos, and I also do knowledge videos to help you guys out and learn how to master car audio. If that kind of thing interests you, check out some of my other videos, and I'd love to have you as a subscriber. So first off, why does air volume for a subwoofer box even matter? Now this applies to a sealed box, a ported box, a bandpass box, any type of subwoofer enclosure. The reason that the internal air volume matters is as we change that internal air volume, we're going to change how the subwoofer performs. As a really basic example, let's think about a sealed subwoofer enclosure. And let's say that that sealed subwoofer enclosure has a very small air volume. In general, that subwoofer is going to have more of a difficult time moving in and out. This is going to mean several different things. In general, that subwoofer in the smaller box is going to have an increased power handling, but it's going to have a harder time playing low frequency notes. Now, what if that air volume is much larger? Now the subwoofer can move much more easily, it can play lower notes much more efficiently, but it's going to have a reduced power handling. In fact, there comes a point that the airspace can be too large and the subwoofer could even be damaged being in such a large air volume. So in summary, the air volume matters because it controls how the subwoofer reacts to the electrical input and then the acoustic output it creates. So when we open up a subwoofer, or if we're looking at specs online, we're going to get a list that looks something like this that the manufacturer provides for a list of volumes to start with for the design of our subwoofer enclosure. These air volumes are going to be an average value that leads to a good response and is safe for the subwoofer. The problem though is there's multiple different definitions for the way that the air volume is listed. And if you don't understand what each one means, you're gonna be off to a bad start. So the first type of volume we're gonna talk about here is the gross volume. And I'm gonna be showing you guys what I'm talking about here on my iPad. So what gross volume means is if you take the depth multiplied by the height multiplied by the width of the total subwoofer enclosure, that's going to give you your gross volume. Now what's important to note is this value really doesn't tell us much. In fact, I really don't like when people actually talk about gross volume. The problem is if you're telling me that a box is 2 cubic feet of gross volume, you're really only telling me the overall size of the box. Knowing the gross volume gives us no idea how large the port is inside, what it's tuned to, what its cross-sectional area is, how much bracing is in the enclosure, if there's any 45s. It really tells us very little about the box. In fact, I could have two different subwoofer enclosures that are 2 cubic feet gross, but they could be completely different. One could have a tuning of a super low 28 hertz, another could have a tuning of a super high 40 hertz, and have different internal air volumes as well. So in summary, it's better that we talk about a different type of volume. The important value that we really need in order to understand how the subwoofer box is going to perform in relation with a tuning frequency, or if it's sealed, just that air volume on its own, is the actual internal air volume. Internal air volume is going to be the gross volume of the box minus all of the different displacements. So we're gonna have a displacement for all the materials in the box, we're gonna have a displacement for the subwoofer, we're gonna have a displacement for the port itself, and we're also gonna have a displacement for other things that are in the box, like bracing, even wire if you really wanna get down to the fine details. Now I know that can be a little bit confusing, so I wanna draw on the iPad exactly what I'm talking about. So obviously here we have a 3D view. It's an exploded view with the front and the top of the box off. But if I kind of draw in an outline, this pink volume in here, that is going to be the internal air volume. Now you have to also account for the fact that the subwoofer is going to be sticking into this in this area, so you would remove that from the air volume, and you also have to account for that brace that's kind of sticking in there. If it didn't quite make sense on that 3D view, here is a two-dimensional top-down view. On the top-down view, the internal air volume is going to be these volumes here. You can see I've drawn around the brace because that's not included in the air volume, and I've also left space for the subwoofer because that's not included in the air volume either. Now, how do we know this volume here for the subwoofer? Well, that is listed as the subwoofer's displacement. The subwoofer displacement is the amount of volume that the subwoofer takes up within the enclosure. But don't get confused, the subwoofer displacement is not how much air the subwoofer moves, it's how much air is displaced volume-wise by the subwoofer being inside of the box. Now that air volume that I just showed you guys, a lot of times people will also refer to that as the net volume. I wanted to tell you guys that net volume is the same as internal air volume in case you saw that term somewhere, but I'm going to tell you why I don't really like the term net air volume. There are some manufacturers out there that will list a net air volume that is recommended, but then they will go on to say that the net air volume includes the subwoofer displacement. But the problem is they don't also include a value for that displacement, which means that I can't take their net air volume and subtract their displacement to determine what their actual internal air volume recommendation is. Manufacturers, if you're out there watching this video, please, for the love of the base holy gods, stop doing this. When these subwoofer manuals are being written, I get the impression that whoever's writing them is trying to dumb things down because they don't think that we will understand. But there are multiple problems with not knowing the actual displacement of a subwoofer. For example, what if I want to mount a subwoofer inverted? If I don't know the displacement, I can't account for that in my calculations. The same goes for what if I want to do a bandpass where the magnet of the subwoofer is sticking into the ported section or the sealed section instead. I can't account for this in my calculations. Now, of course, you can take the approximate size of the subwoofer and you can do a rough estimate for the subwoofer displacement, but if a manufacturer is truly actually designing their subwoofers, they should have blueprints, they should have 3D models, and easily be able to provide that information to the consumer. Sorry for the rant there, it's just a little bit of a pet peeve of mine, and it kind of makes me wonder if a manufacturer can't list that displacement value, how much of the subwoofer are they actually designing, or are they just picking a bunch of different components from an overseas build house and having that thrown together for a subwoofer? Manuals and subwoofer spec sheets should not be missing that important part of information. So we understand that the hatched area here is the air volume, and that's important because the air volume in relationship with the port tuning is going to tell us how the subwoofer in this box is actually going to perform. So as an example, let's say that a manufacturer is telling us for a 10-inch subwoofer, you need a 1.25 cubic foot of airspace subwoofer enclosure. So in that case, when we're designing our custom sub box, we would want that hatched area to be 1.25 cubic feet. We would take that 1.25 cubic feet and add the subwoofer displacement, we would add the port displacement, we would add all the material displacement, including any internal 45s and bracing, and all of those values together would then bring us to the gross volume. Now there's something else that's super important to understand here. This recommended air volume that we get from the manufacturer, it's just a recommendation. It's a starting point. It's what the manufacturer feels will be a good average air volume for the average listener in the average vehicle. But if we're designing a custom subwoofer enclosure, we're going to know your musical preferences. We're going to know the exact vehicle that you're going to use, along with obviously what subwoofer it is. So we can adjust that internal air volume along with tuning in order to control how the subwoofer actually performs. That way we can optimize for max output, or we can optimize for a more musical response. Everything is about a trade-off. And that's another one of my pet peeves. I wish that manufacturers wouldn't say this is a required airspace. They should always list a range. You should have at least this much air volume, but not exceed this much air volume. Unfortunately, when they say it's a required air volume, we end up with people that get confused and don't think that there's any value to adjusting and deviating from that internal airspace. So moral of the story, the internal air volume that the manufacturer lists is a starting point. Much like we can change our tuning frequency to control how the subwoofer actually performs, we can do the same with the internal air volume. Now, as another side note, I'm just trying to give you guys as much information as I can here. Another thing that's really critical to take into account is the subwoofer itself. So as an example, let's say that you have a 2 cubic foot box tuned to 32 hertz, you put one subwoofer in it and you record how it plays, and then you put a different subwoofer in it and record how it plays. Obviously, those two subwoofers are going to play in that exact same box differently. This, my friends, is why we have to take into account the TS parameters of a subwoofer. I have a full video up here. Now, if you find this information overwhelming, but you still want to build your own custom subwoofer box, keep in mind that you can purchase a custom subwoofer box design from my website. You and I will work together to take into account your musical preferences, your vehicle that you have, and your actual subwoofer in order to get the best performance. You can learn details about that down in the video description. My final little bit of advice for you guys is you should definitely have a plan and a design before you even purchase your subwoofers. You should know that the amount of space you're going to use is going to work well and that those subwoofers are going to meet your performance expectations before you end up with something that isn't going to. If you want to see some more of my videos, you can check them out here. I'd love to have you as a subscriber, and a special thanks goes out to John, Brian, Ali, Steve, Emmanuel, Jerry, and the rest of the Patreon membership team. A big thanks to all those guys for helping make these videos possible. You can check that out down below as well. Thank you, my friends, for watching.